Look at those factorials. So factorials, if you use the ratio test, they quite often cancel out. So I'm going to do that. Use the ratio test. So you take the n plus 1 term, so substitute n plus 1 for all of those n's, divide by this term, and then take the limit as n goes to infinity. So take the n plus 1 term is going to be 2, and then n plus 1, and then all of that is factorial. This one is n plus 1, that's factorialed, and then all of that is squared. And then also in the numerator, there's x to the n plus 1. Now divide by this term itself, or in other words, invert and multiply. So this is the numerator, n factorial being squared. This would then be in the denominator, and this. So what's going to cancel? Well, obviously the xn and xn will cancel, leaving a single x. One detail I forgot is that x can be positive or negative, so we take the absolute value of this. And what about this? Well, if you multiply this out, this is 2n plus 2. So if you have 2n plus 2 factorial, something like 12 factorial, then you could say, well, that's going to be 12 times 11 times, and then you could just say 10 factorial for the rest. So in other words, you could count off a couple of the terms and then just say the rest is factorial. So that's what I'm going to do here. I'll say that means that that is 2n plus 2 times 2n plus 1, and then I'm down to 2n, so then it's going to be 2n, and I'll just factorial the rest. Okay, so limit as n goes to infinity. I'm going to move this one over here. Okay, then this one, like I said, count it off as 2n plus 2, 2n plus 1, and then 2n factorial. That way, the 2n factorials can cancel. Over here, well, this is squared and this is squared, so what we could say is that means the whole thing is being squared, where this is n factorial and this is n plus 1 factorial, and then there's a single x. So now we're ready for the canceling. 2n factorial and 2n factorial cancel. So this is saying something like 10 factorial divided by 11 factorial. So that means that pretty much everything cancels except that 11. Or in this case, the n plus 1 being squared. Okay, almost got it. The numerator has this, which I'm going to go ahead and multiply out, is 4n squared plus 4n plus 1. This is n plus 1, so the way that we cancel it is n factorial cancels the factorial. So the denominator here has n plus 1 being squared, so that's n squared plus 2n plus 1. Now if you take the limit as n goes to infinity, then this and this tell you what's going to happen with the n's. It's going to be 4n squared over n squared, that's a 4. Or you could do L'Hopital's rule twice, and you'll end up with the same thing. So this means that we've got the absolute value of 4x. Then the ratio test says that that converges if this is less than 1. So in other words, 4x is sandwiched between 1, -1, or in other words, x is between -1/4 and 1/4. Then we would need to substitute those. Oh, wait a second. It doesn't say find the interval. It says find the radius of convergence. So the radius is, you go 1/4 this direction, you go 1/4 that direction, so the radius is equal to 1/4.